42 integral of inverse tangent x over x squared dx. As I said, these are going to get more challenging now. So for this one, if you remember from lecture or hopefully from homework problems, hopefully you did it before, the integral of inverse tangent x, we need integration by parts to do it. So maybe we need integration by parts here as well. Because otherwise, I don't see a nice u substitution to do, at least right off the bat here. Not standard trig integral. I definitely don't want to do a trig sub. And I definitely don't want to do partial fraction decomposition on arctangent x. Even I don't know how to do that. Okay. You might need a power series or something like that, which you probably didn't learn at this point. But anyway. So let's try integration by parts. So let's let u be inverse tangent x. Du is 1 over 1 plus x squared dx. dv is what's left, 1 over x squared dx. So v is minus 1 over x. Okay, so uv minus integral v du, we get minus inverse tangent x over x minus integral v du. There's a minus already at the v, so it becomes plus integral 1 over x times 1 plus x squared dx. Do we know how to integrate this guy? We do. Partial fraction decomposition. We do need it in the end here. I'm going to erase this to make more space for myself. So we have 1 over x times 1 plus x squared. This is a over x plus bx plus c over 1 plus x squared. That's a quadratic term, so you need a linear thing on top. Okay. Multiply both sides by the denominator. We get 1 is equal to a times 1 plus x squared plus bx plus c times x. Okay, we can even mix and match the techniques. We can match coefficients. So we get what? We get a x squared plus a plus bx squared plus cx. So 1 is equal to a plus b x squared plus cx plus a. Okay, actually this is easier because this constant needs to equal this constant over there. So a is equal to 1. There's no x squared term on the left, but there's an a plus b times x squared on the right. So b must be negative 1 because a plus b must be 0. And c must be 0 because there's no linear term, or to the first degree term, I should say, on the left-hand side. Okay, so there's our partial fraction decomposition. So we get 1 over x, and then minus x over 1 plus x squared. Okay. So now let's integrate this. This is negative arctangent x over x plus natural log absolute value x. That was the easy one. This one, let's do the substitution in our head. It'll be, we need a half and natural log of 1 plus x squared. Let's differentiate it real quick to check our work. It'll be 1 over 1 plus x squared times 2x. The 2 and the half cancel, so we're good there. Plus c. Here's our answer. All right, so this one, once again, from experience, hopefully we remember that we needed integration by parts to find the integral of inverse tangent x. And it's also maybe it was a good idea to do it again in this one.